All right, we got some more examples here regarding stress and strain calculations. Stress being essentially the pressure or force over a given area that an object feels or is under, um, and strain being how much stretch over the original length as that force is applied to that component. So I have a couple examples here. It says a weight of 18,000 pounds is supported on a rectangular base plate that is 9 inches wide and 2 feet long. Okay, so I have a rectangular base plate that is, what did it say, 9 inches wide, 9 inches by 2 feet long. Okay, so as you can see that this is definitely not drawn to scale because I have the 2 feet smaller than the 9 inches, but whatever. Okay, so here I have some sort of force F applied, and we're actually told that this is 18,000 pounds on this plate. 18,000 pounds. Okay, so a lot of weight on this rectangular plate that's 2 feet by 9 inches. So it says determine the stress that the base plate exerts on the concrete slab. So I have the force being applied to the plate, and then there's a concrete slab beneath that. Okay, so here it says stress. Well, I have a stress equation. You can find it in your engineering formula sheet. I hope you've opened it up and have taken a look at it. You'll see that the stress equation is equal to force divided by area. So force that's applied over a given area. Now, in the imperial system, this is measured in pounds per square inch, so PSI. So this is actually very easy to calculate. It requires me to calculate the area of this base plate, which is easy. That's equal to 9 inches times, and you don't want to mix your units, so let's convert this 2 feet to inches, which would be 24 inches. All right, go ahead and use your calculator to calculate what that is. You have it? All right, you should have gotten 216 square inches. So that's the area of that plate. So my stress is equal to 18,000, and that's an equal sign, by the way, 18,000 pounds divided by 216 square inches. So go ahead and put that into your calculator, and you should receive an answer of 83.333, 3 repeated, so I'll just round to 0.3 pounds per square inch, or PSI. Now what does that mean? That means for every square inch, every little square inch, so if we look at this rectangle here, every little square inch, you have 83.3 pounds on it. 83.3 pounds. So once we add up all those square inches in this entire rectangular plate, it should add up to a total of 18,000 pounds. So this is the pressure or the stress that's exerted on that concrete. Okay, now it does want it in pounds per square feet as well, so you can convert this square inches to square feet and get an answer. Let's take a look at the second example here. Second example says a 1/4 inch diameter rod must be machined on a lathe to a smaller diameter for use as a specimen in a tension test. Okay, well there's could be a few words here that you may not be familiar with. So one is a lathe. Okay, so what does a lathe do? So here I have a rod. So think of a really skinny cylinder, probably drawn not the best, but you get an idea. Okay, so I've got a cylinder here, and what we're going to do is that lathe is going to turn this cylinder to a smaller diameter, kind of like those dog bones that we used for tensile testing. The dog bone kind of did this towards the center. It was big, wide diameter, and then it got to a small diameter. So what this lathe does is it rotates this rod really, really quickly, and then you come in with like a cutting bit, some metal cutting bit, and you start pressing into the material, and it starts chopping away and cutting material away from this rod, and you start turning it down to a smaller diameter. And as you move this bit left or right, you start to change the, that a region of this rod becomes smaller in diameter. Okay, so that's what a lathe does. So that's what we're doing. Okay, so we have this 1/4-inch rod. So let me go ahead and draw it again. And I'm not going to, it's a 1/4-inch diameter rod. So 1/4-inch diameter. Okay, so that's a circle with that line through it for diameter. Let's see, the rod material is expected to break at a normal stress of 63,750 psi. So we're told that this thing can only withstand a stress of this much, 63,750 psi. Okay, that's pounds per square inch. All right, and we're also told that if the tensile testing machine can apply no more than 925 pounds of force. So that machine can only apply 925 pounds of force. 925. Okay. Calculate the maximum rod diameter that should be used for the specimen. Maximum rod diameter. Okay. So when we work on stress problems, for example, stress is equal to force over area, right? And if this rod was going to experience a force, like a tension force, for example, notice it says tension test. So that means we're going to take this rod and we're going to pull on it in both directions with some force. Okay, so we're not only going to pull downward, but we can hold it stationary and it's going to pull upward as well. So it's going to be stretched. Okay, the area is this cross-sectional area. So if I took a slice and I sliced it down here, that would be a circle. Okay, so we know the area for a circle is pi times radius squared. Okay, so now I've got all the bits and pieces that I need. I have the stress that this rod will break at. I have the maximum force. So the only thing I need to do is substitute pi r squared into this area and then solve for my radius. Okay, and then it says calculate maximum rod diameter. So after I do that, I can multiply by 2 and have the diameter. Okay, so it's a very easy problem. You just write down what you know. 63,750 psi for my stress. 925 pounds is the maximum force the machine can apply for the tensile test. So I have stress, I have force. Now I just need to calculate the area and then go backwards and solve for R. So it's just a simple algebra problem. So let's go ahead and do that. 63,750 psi, or pounds per square inch, is equal to 925 pounds handwriting's a little weak here, but you get the idea, divided by pi r squared. Okay, using algebra, you can go ahead and let's move this r squared to the other side and divide by that 63,750. So I have r squared is equal to 925 pounds divided by pi times 63,750 psi, but I'm going to go ahead and expand that so you can see pounds per square inch. Okay, so if I take the square root of both sides, square root and the square drop out, leaving me r is equal to square root of 925 over pi times 62,750. Okay, now as far as my units are concerned, my pounds will drop out, the square and this inches will cancel out with the square root, and I'll have my answer in inches, which is exactly what I want. So go ahead and take out your calculator and go ahead and perform that calculation. So again, it's the square root of 925 divided by pi times 63,750. And I end up with a radius of 0.068 inches. And again, that's radius. What did they ask for? They said, what's the diameter? So diameter will be twice that. So multiply that by 2, and I end up with 0.136 inches as my rod diameter. Alright, so again, here's a couple of stress-strain examples. They're not hard. Identify the information that you have, and then substitute the values into the equation. Solve for your unknown. It's really that simple. Thanks for watching.